Hey guys, welcome to Michelle's STEM Journey. I am Michelle and this is an educational channel where I will be sharing with you all my journey navigating through the STEM field. I am currently a freshman in high school, and because I am very interested in math, I will be posting an AMC video each week and sharing with you all how I solved it. So for those who don't know what the AMC is, it is short for the American Mathematics Competition. And before I begin, I would just like to say that my brief introduction all comes from the AMC official website, which will be linked down below. So the AMC has three parts: the AMC 8, 10, and 12. The AMC 8 is a 25-question, 40-minute multiple choice test, and those who are in 8th grade or below can take it. AMC 10 and 12 are both 25-question, 75-minute tests, and you can take the AMC 10 if you're in 10th and 9th grade, and you can take the AMC 12 if you are in 11th and 12th grade. AMC 10 and 12 both have two tests that you can take, the A and B tests. The only difference is that they happen on two different dates, usually a week apart. And all of the AMC tests are school-based, so if you are interested in taking it, be sure to ask your teachers about it. And now that we know what the AMC is, let's get started with our problem. The problem states, an even number of circles are nested, starting with a radius of 1 and increasing by 1 each time, all sharing a common point. The region between every other circle is shaded, starting with the region inside the circle of radius 2, but outside the circle of radius 1. An example showing 8 circles is displayed below. What is the least number of circles needed to make the total shaded area at least 2023 pi? It tells us that the radius of this circle is 2. The radius of this circle is 1. So we can figure out the area of the shaded region. So the shaded area would equal to 2 squared pi minus 1 squared pi. This would give us 3 pi. And then we can do one more. Now we will be setting up an inequality because it says at least 2023 pi. So this side of the inequality is the total shaded area. And the total shaded area is at least 2023 pi, which means it would have to be greater than or equal to 2023 pi. Now we have the first two shaded regions, so we can just put that right here. 3 pi plus 7 pi plus the middle, the rest of the shaded regions, and then you plus the very last shaded area, but we don't know what that is. So we can use C. Let C be the last shaded area. And then 2C would be the number of circles, because it takes 2 circles to make up one shaded area. And so we can use 2C squared pi minus 2C minus 1 squared pi. This is the area of the very last shaded region. And we can then just put that right here. Now, if you notice that both sides of the inequality has pi, so we can just cancel pi out, which gives us just 3 plus 7 plus the middle parts plus 2c squared minus 2c minus 1 squared, greater than or equal to 2023. And right here, this is a difference of squares, so we can simplify this. It would be 2c plus 2c minus 1 times 2c minus 2c plus 1. This was simplified to 4c minus 1. So just put that right here. Now this is an arithmetic sequence, and we can simplify the left side of the inequality, which would give us the first element, which is 3. I'll put it right here. 3 plus the very last element, which is 4c minus 1. Multiply that by the number of elements, which is c, divide by 2. This would simplify to 2c plus 1 times c. And this would be greater than or equal to 2023. You could solve this inequality and get c, and then you multiply by 2, because keep in mind that 2c is what we are looking for. And the answers are 2c. But I am going to plug in the answers. For example, a is 46. Plug in 46, which would be 46 plus 1 times 46 divided by 2, which is 23. And test whether or not it is greater than or equal to 2023. So this actually gives us 1081, and that is not greater than or equal to 2023. So A is not correct. And then you can just try the rest and see which one satisfies inequality. So after plugging in the numbers, we see that only E satisfies this inequality. Therefore, E is the correct answer.